thanks for coming for this workshop. In this workshop, I'll very quickly show you how you can get started with zkEVM, how you can build your projects on zkEVM. But first of all, GM, or I should say ZM, because we are moving into this world of zk, right? So, what is Polygon zkEVM? So Polygon zkEVM is an EVM equivalent zk rollup. It harnesses the power of zk to reduce the transaction cost and increase the throughput. And why Polygon zkEVM? We feel that it's the next chapter of Ethereum scaling. So it's very exciting for developers because you can use all the same tools and technologies that you have been familiar with, like different wallets, like tools for developing smart contracts like Foundry, Hardart. You can code in Solidity. So it works pretty seamlessly. They all work out of the box. Just I need to highlight that the only thing is that that I want to call out is that we don't support 3 pre-compiled opcodes. So if you're building on that, just be aware. Otherwise, everything works pretty seamlessly, which is very great for a dev. So first half of zkEVM is zk. I'll explain this with an example. So everyone must have played this game called Where is Waldo in their childhood. Basically, it's kind of a puzzle, and you want to find out, like you need to figure out where Waldo exactly is, right? So, so what if I say I know the location of Waldo, but I can prove to you without actually revealing the actual location of it? How am I going to do it? So I'm going to take a big piece of black paper. I'll cut out the shape of Waldo and I'll place it over the picture. So in this way, I can prove to you the exact location of Waldo, but I could have placed the puzzle in any of the corners or anywhere around the black paper. So in this way, you don't know what's the location. Only I know, but I have proved to you that I know the location. So this is technically how zk works, right? So in real life, zk works with complex maths and cryptography to prove a validity of a statement without actually revealing that statement. So we have talked about zero knowledge, but what exactly is a rollup? So zero knowledge rollups are layer 2 scaling solutions that increase the throughput, basically they scale Ethereum by increasing the throughput and reducing the transaction cost. Yeah, so in case of a zk rollup, zkEVM rollup, so zkEVM rollup is technically a zk rollup that is designed to mimic the same transaction execution environment as mainnet Ethereum or Polygon POS or any other EVM chain. So what's the benefits and features? So it enhances the Ethereum's battle-tested security. So the proof is being posted on Ethereum, and Ethereum has been running successfully for years, right? So we trust it. We love it for DeFi. It's scalable. We achieve this scalability by batching many transactions together to unlock higher performance, right? And obviously it brings down the cost gradually low, and it's EVM equivalent. So the benefit, as I explained before, is that you can use all the tools out of the box. So I'll quickly explain the architecture of Polygon zkEVM. So think about this as a transaction lifecycle. So we'll get into a small journey from where a transaction is sent by a user till this transaction is completely final on Ethereum, right? So we start by receiving this transaction on the node, sent by a wallet or any script based if you are working on a project. So this transaction goes to a pending transaction pool, and at some point, the sequencer, you can see there, to the top, like right, uh, it's part of the node. It picks up the transactions, it executes these transactions, and then puts them into an order. So this ordering is actually what we call as the trusted state. It's trusted because it's not yet on layer 1. And the sequencer essentially just says that, hey, this transaction will be included in this block. This info is then can be shared to the other nodes in the network by the broadcasting service, and this information can be shared to the users as well. So this is this is where we actually achieve the first level of finality or first level of confirmation, right? Then after a certain time, the sequencer have when it has accumulated enough transactions in the trusted state, it'll send these transactions in a batch to layer 1. It sends it to the rollup contract that's called as Polygon zkEVM.sol, to be precise. So you can see the contract there. So the main goal of this interaction is to put the DA, the data availability, on Ethereum. Basically the data of the transactions to Ethereum. After we have done that, the key point is that any node in the network can then read this Ethereum smart contract and rebuild the state using this info. And we can rely on the data that is posted on Ethereum, because what's on Ethereum, it will stay there for long enough, we hope, right? And now because of this, we can rely on the state of layer 2 rollup as it's on Ethereum, right? It is what we call as virtual state. Now here we realize that we haven't talked much about zk, right? It's zkEVM. So here's the thing. Although we have this data on Ethereum, but like the Ethereum smart contract doesn't understand the processing of these transactions. It just knows that there's bunch of data, and in order to make it aware of the latest state of layer 2, it's when we need the zk proof. There is another role in the node called aggregator, which will fetch this data and generate a zk proof after talking to the another service called prover, and say, hey, after processing this data, the state of the network is this, and of course we compress the this state into a hash, a Merkle root to be precise, and then submit this zk proof to Ethereum. This state is called consolidated state, and that's how we are scaling transaction while we are inheriting the security of Ethereum. So these are the three stages of finality that I talked before: the trusted, virtual, and consolidated. So it's the trusted state where the batch generation and the broadcast happens to the L2 node, and it's basically given by the trusted sequencer. Then we have the virtual state where we are putting the data availability onto Ethereum, and then we have the consolidated state where we are generating the proof and we are actually putting this proof on Ethereum. So yeah, some of the industry use cases and things that we are really excited you all will be building this weekend are DeFi and in TradeFi space when you are transferring value. So like when you are transferring value, you want high levels of security. So for finance, we highly suggest using zkEVM. Even like in other use cases like healthcare, gaming, supply chain, you need high level of trust. We highly recommend using Polygon zkEVM when you are figuring out what chain to go for. So to get started with building with Polygon, you first need to bridge some funds from Ethereum, and technically you need to bridge Ether from Ethereum to get zkEVM ETH that you can use to submit transactions, pay for gas fees, etc. Right? So you can do that by going to wallet.polygon.technology. There you can just select based on if you want to go for testnet or mainnet. You can select the network, you can select Ethereum, and then basically you can just click the button start bridging, and you will have zkEVM ETH in your wallet. So for mainnet, it's obviously you need to bridge over the real ETH, but for testnet, what else you can do is go to faucet.polygon.technology, paste your wallet address there, and click Polygon zkEVM there, the network, and you'll receive zkEVM ETH. Yeah, so as you can see, it's very simple to deploy and get started with zkEVM, and swapping your development environment from Ethereum or any other EVM chain that you're using to Polygon zkEVM. And this can happen just by changing one line. That is basically changing the JSON RPC. So that's really what you need to do. So I'll just show you how we can do this very quickly using Hardart. So I'll just jump to VS Code. So this is a very basic project of Hardart, and I have a contract here called greeter.sol that you get out of the box with Hardart. So in this contract, you can see we have the pragma statement. Then we have a constructor function. We have a view function that is greet to actually see the value of greeting that we have defined here. So the contract is maintaining the state of this particular variable. We can use this function to get the value of greeting. We can use the set greeting function here to actually see what is the current value of greeting, and we have this constructor function to set the initial value for greeting. Then I've written this small deploy.js script. This is to actually deploy this contract. So I'm using this dependency called hard@ ethers, and I'm calling this deploy contract method to create an instance of the contract and then deploying it. Then I'm just printing this, printing the address for the contract that I've deployed, right? So what I was mentioning was that how you can just deploy on Polygon. You just need to change one line of code, right? So it's this simple line of code that I was referring to. That's the JSON RPC. So in the this is the config file, right? So in the I've named the network as zkEVM. I'm mentioning the URL, and I'm also mentioning what my private key is so that to make Hardart aware of from what account I want to deploy my contracts from, right? So I've put the value for this in my .env file. So if you just want to deploy this contract, what you can do is say npx hardhat run, and I want to run this particular deploy.js file. So I'll just say scripts. It's in scripts folder. Say deploy.js, and I'll just select the network, which is in this case is zkEVM, and I'll just hit enter. Yeah, as you can see, the contract, I'll just move this up a little bit. So as you can see, the contract is deployed to this particular address. We can go and have a look as well. So for that, we have the explorer at zkevm.polygon.technology. zkevm.polygonscan.com. And for testnet, it's testnet-zkevm.polygon.com. So right now, as I've deployed it on testnet, you can, I've just copied the address. I'll just paste it here. As you can see, it was deployed 1 minute ago. So I was able to do it because I had some funds in my wallet. But for you to get it, again, you can just go to wallet.polygon.technology to bridge over the ETH, or you can go to Faucet if you're developing on testnet. So yeah, that'll be all from my side. Thank you. Anyone has any questions?
Oh, that's good.
Yeah.
Right? Let's say that I'm going to need to go after this room. I have to leave. So I'm in the or more get a spend on the gas, but what that?
So yeah, so the gas price is definitely a lot less than Ethereum, but for a for NFT use case, probably I'll say you can choose whether you can go for POS or you can go for zkEVM. What zkEVM gives you, like other than POS, is that it gives you a high level of security as it's a roll up. Okay. So yeah.
Okay. Yeah. Thanks.
The question. Yeah.
Let's say
Hello, I could not quite understand what was meant by changing one line in the module. What was meant by changing one line in the module.exports?
Yeah. So basically, if you're developing on Ethereum or you were developing on any EVM chain, let's say Polygon POS, and you are already you already have your contracts, right? You must have deployed them using any of the smart contract development framework like Hardhat, Foundry, or you can do it via Remix as well. So technically, the whole idea was that you don't need to change anything with respect to contracts, right? You can just connect to the RPC and deploy your contract there. So in the line, I'll show you. I'm just mentioning which network I need to connect in. So if let's say I just mention the RPC URL of Ethereum here, the contract would be deployed to Ethereum. Or if I mention the RPC URL of Polygon POS, it will deploy on POS. So the whole idea of this one line change is that it's very easy to deploy on zkEVM, that you don't need to change anything. The dApps that you are already familiar with or you already have built, they can straight work out of the box with zkEVM.
So actually, how can you say that you are? How can you say that you are achieving much more throughput rather than the traditional method? Although you are doing much more computation to the zk calculation you are doing. So how can you say that you are achieving much more throughput in zkEVM process rather than the traditional method?
So you're saying with respect to Ethereum?
Yeah.
Yeah. So in Ethereum, as you know, there's a block time of 15 seconds, right? So the throughput is really less. And here, what traditionally we are doing is we are batching all the transactions and then submitting them on Ethereum. And if you see, if you're just in Ethereum, whenever you want to transact, there's a separate transaction for every transaction that you're doing, right? Every thing that you need to change the state of Ethereum for, right? But with zkEVM, what you're traditionally doing is that you're batching all those transactions and then just submitting one transaction on Ethereum. Basically, that's submitting the validity proof to it. So the throughput is much more than that.
Okay. And he's
after now, that's not that longer beware the demo.
Any other questions?
We have plenty of time, so please take advantage of the time. We still have a whole another 10 minutes. If anyone would like to ask a question, come on closer too, so we can hear you better for those in the back.
Can you hear me?
Yeah.
All right. I have a bunch of questions, I guess. So as I understand, like the whole system is basically zero knowledge proofs based rollups, right?
Mm-hmm.
How it is being batched and how it is being submitted to Ethereum.
Right.
Now, from an EVM perspective, do you have anything extra that has been added, which sort of gives smart contracts maybe zero knowledge proof sort of functionalities or something like that you can execute?
No. So from smart contract level, it's exactly the same. If you compare it with Ethereum and POS, what we are leveraging zero knowledge proofs is just to scale.
For basically the roll up thingy
Yeah,
and the batch
exactly,
thingy.
exactly.
Now, which that also means that the transactions on the whole system are actually visible. The transactions themselves are not zero knowledge, right?
Yeah, yeah.
Are there any plans in which like you have either this network upgraded to, or maybe a new network in which the whole network itself is zero knowledge, so that like you basically cannot see who is doing what?
Yeah. So the thing here is that with zero knowledge, yeah. So zero knowledge here, how it is being used is that when I am transacting on Polygon zkEVM, I am like all the transactional data stays on zkEVM itself. It's just that the summary is posted on Ethereum, right? So if you see, Ethereum doesn't know about that data, but still it knows the state of zkEVM. So in that sense, it's zero knowledge for Ethereum, right? But to your point, I think we don't have any plans for that, because technically, if you want the whole chain to be zero knowledge, that's actually the role of consortium or private blockchains, right? And as you know, our main vision is to scale Ethereum, which is a public chain. So we are gonna have a public chain, yeah.
Got it. I mean, you can have a public chain also in which you have zero knowledge based transaction. I think Aztec initially was trying to do that or something like that. But yeah, like that completely depends upon what the plans are. But yeah, thank you.
Excellent. So through zkEVM, we are creating a zk proof of our smart contract. Can we say that?
No, you technically you can say that you are technically just creating a proof of the latest state of zkEVM and then posting it on Ethereum, so that Ethereum is aware of the latest state of zkEVM. This is this is very useful when you are bridging, basically. So to bridge, if you want to do it from Ethereum to zkEVM, you can just zkEVM can just fetch the state of Ethereum and know that you have deposited your funds, right? But in order to withdraw back to Ethereum smart contracts or Ethereum should also be aware of the state of zkEVM, right? So that is done via the zk proofs.
Okay, thanks. Thank you.
Hello.
Yeah.
So from my understanding, so it's like we are having a normal Polygon chain, and this zero knowledge chain is like a different one, right?
Yeah, both are very different. So the zkEVM is a roll up, and that's traditional POS chain.
Yeah, yeah, got it.
This works on a consensus mechanism known as proof of efficiency.
Yeah.
So yeah, completely different chains.
Yeah. So my question is like, just from a perspective of one who develops the dApps or just a contract. So when can I like decide? Okay, this is the right time to use this zero knowledge chain. So like, can you give like maybe a direction like?
Yeah. So basically, if you still have a lot of transactions, or you don't really, if let's say you are building a dApp in DeFi, right, or you are building a DeFi product, then security is very essential for you, right? You don't want your funds to be, you don't want someone to steal your funds or go somewhere else. I'm not saying that POS is not secured, but zkEVM is much more secured than POS, right? So the thing is that if security is your thing, you should go for zkEVM. But some use cases like NFTs, where you want a lot of transactions, and if you see the gas fees, it's still the gas fees on POS is cheaper than zkEVM, right? So if you want to go for like bulk transactions and low gas fees, you can select POS.
Actually, our one of our use cases is like we want to include a lot of NFT minting. So would you suggest like go for the zero knowledge chain?
Yeah, you can totally go for zkEVM. In that case, it'll work totally fine.
Okay, thank you.
Excellent. Can we visualize the zk proof anyhow, like what is the zk proof of our smart contract, and can we verify the zk proof we are generating is actually representing our smart contract? Is there any way of doing that?
Uh, so you're basically saying of your smart contract?
Yeah, like our smart contract, we are creating the zk proof of our smart contract. So like can we say, is there any way to verify that the proof we are creating is actually mimicking the smart contract of like
Okay. So yeah.
trust, like,
So
setting?
you're not creating a proof for the smart contract. When you are transacting with that smart contract, you're creating a proof for that, right? And then basically when you're submitting the proof, so let's say you send a transaction and that changes the state of zkEVM, right? Now for Ethereum to be aware of that state, you are sending that proof there. So yeah.
Yeah, I got it. Yeah, thank you.
Yeah, can you hear me? Oh, yeah.
Yeah.
Yep. So you mentioned that you have some certain opcodes which are not compatible with the zkEVM, right?
Yeah,
Like some-
it's just 3 pre-compile opcodes. Other than that, all the opcodes are supported.
yeah. Like, so how can we know which are those opcodes so we can, like, avoid it in our contracts when deploying?
Yeah, so for that you can just go to wiki.polygon.technology. I can just show you quickly as well. So here's the documentation. So here's the quick start guide to actually, here you can find the RPC details about the testnet and zkEVM. And if you go to FAQs and you go to EVM equivalence, yeah, you can just see that these precompiled are not supported. It's SHA-256 Blake and pairings. Other than that, all the opcodes are supported.
Thank you.
Any other questions? Still have 3 minutes.
Actually, I'm trying to build a DApp, DeFi DApp, which is trying to run a job and that job will be containing hundreds of transactions. So can I do that in zero knowledge?
zkEVM, you
Yeah.
mean? Yeah, totally.
Okay, because in Ethereum mainnet, the gas prices are exorbitant.
Yeah. So if you see with Polygon zkEVM, the transaction fees are very low as compared to Ethereum. So even if you see the contract that I deployed, it's like only it's 0.0000025 ETH is the transaction fee. In case of Ethereum, it would have been much more than that. Yeah. So you can totally use zkEVM for deploying it app.